Hi guys. What can I say? I don't know that I was meant to be a virtual teacher. Those technology problems were definitely the worst yet. But anyway, here we go. So these are the notes that we should have finished taking in class if we could all not freeze for a consecutive minute, but that didn't happen. So if you missed this, we had done this one and this one, but I know not all of you saw that. So equivalent ratios, remember, they are equal to each other, two ratios that are equal to each other. Obviously, they don't look like they have the same numbers in them, but the relationship between the two numbers is the same, meaning that I could take both the numerator and denominator of one of the ratios and multiply or divide it by the same number to get the other ratio. That will make them equivalent ratios. So in this case, I noticed that 4 can be multiplied by 4 to get 16. So to make an equivalent ratio, I would also have to multiply the denominator 7 by 4. And that would give me a 28 here, right? 7 times 4 is 28. So I would say the value of x is 28. For B, the nice thing about having a video is you can always pause it and go back, right? If I'm too fast for you. So for B, again, here was the original ratio, and I want an equivalent ratio, but I want the denominator of the new ratio to be a 4. So I have to look at what I could do to 36 to get 4, and it has to be multiplication or division. So for my math facts, I know that 9 times 4 is 36, so that if I divide 36 by 9, I'll get 4, but then to make an equivalent ratio, I also have to do the same exact thing to the numerator, divide by 9. So 27 divided by 9 is 3. So the value of y has to be 3. Right? For E, 8 is to 24 as 3 is to, I don't know. So they called it D this time. So the trouble with this one is the two known numbers, the numerators, it's not really super clear to me what I would have to multiply or divide 8 by to get it to become a 3. So, and there is a number, it's just not a whole number, right? It's going to be a decimal or a fraction that I could do that with. So what I'm going to do is I'm going to look at this ratio that I know both pieces of, 8 over 24, or 8 to 24, and I'm going to try to write an equivalent ratio for this. And maybe the new ratio that is equivalent to this one will give me a more friendly number up top, meaning something that I can manipulate to get this 3. So I noticed that 8 and 24 have something in common. They both have an 8. So if I divide both of those by 8, I will get an equivalent ratio. 8 divided by 8 is 1. I'm just going to rewrite it down below since I don't have room next door. And then 24 divided by 8 is 3. So these two ratios are equivalent. So now I want that to be equivalent to this one. So I'm going to bring this one down as well. 3 to D. So this one I like better because I can see that 1 is going to have to get multiplied by 3. So now if I multiply the denominator also by 3, 3 times 3 would give me a value of 9 for D. And then I will look at one more, G. So 15 over something is equivalent to 10 over 12. So again, I'm going to first focus on the numerators in this case because I know both of those numbers. So the question would be, I'm kind of trying to figure out what h is. So is there something I could multiply 10 by to get it to become 15? There is, but it's actually a decimal. So I'm going to try to see if I can make this ratio an equivalent ratio, but with different numbers that might help me get this 15 a little bit easier. So I noticed that both 10 and 12 are even. So if I divide both of them by 2, I can write an equivalent ratio for that. I'm going to do it right below. So 10 divided by 2 is 5, and 12 divided by 2 is 6. And you can see what I see. I do like the 5 because now if I just bring this down, 15 over h, now I do have something that I can multiply the 5 by to get 15, right? 5 times 3 is 15. So I'm going to do the same exact thing in the same order. So 6 times 3 would be whatever h is. 6 times 3 is 18, so h must be 18. All right, and then I'm just